what I'll talk about today primarily is how you can use AI to attack. I'm the founder and CEO of Hadrian. It's a company based in Amsterdam, and we build attack simulations driven by AI. And we do that primarily for larger enterprise. We're now around 100 people, so it's actually now quite a sizable security force in the Netherlands, which is always nice to see some innovation happening locally. I want to start by just quickly referencing something that we had seen this weekend, which Anthropic, one of the large labs in Silicon Valley, came out with news that they had identified large-scale attacks using their Cloud 4.5 model. I won't go too deep into what they actually published, but it basically boils down that, in their opinion right now, fully fledged attacks can be done almost completely autonomous with just a slight human in the loop on a couple of key critical moments, meaning that it's actually substantiating evidence that we already saw before, that close to 80 to 90% of cyber attacks can now be automated through AI. And that's something that you see in the data, right? I'm pulling here from mostly the Verizon report that comes out every year. 70% of breaches are caused by attacks through exploitation, technical exploitation, or using identity. And those are often attack factors that are definitely also now very usable by AI. And we're also seeing that the speed of exploitation and the speed of attacks is increasing very fast. Also, again, something that is on one hand driven by general automation, doesn't always have to be AI, but very much also driven by the fact that it is more or less democratized to be a threat actor today, right? It's not that difficult anymore. So today what I want to take you through is actually just give you a live demo on how you can use an LLM in AI, how we use it at Hadrian, and see a little bit the thought process on some of these attack chains and how they can be used. I'll obviously go over a very simple example because we only have 30 minutes, and well, if you want to go very deep, you're going to just need a lot more time. But it should give you a bit of an idea how these LLMs are becoming stronger and stronger, and also definitely a tool in the tool set of a threat actor today. So when you talk about exploit development, and especially using LLMs for exploit developments, there's basically 4 key topics that we look at. There's the training of the data, which obviously makes sense. You should train it based on historical exploits and software around it. There's the actual outcome, the exploits that you've generated. There are safety checks that we need to perform in order to make sure that the exploits cannot cause any damage when we run it. And then, and this is actually the most complicated step, you need to verify that you are successful in exploiting. And this is actually interesting because my background as an ethical hacker, I've been ethical hacking since I was 12 years old. One of the most common things is that it's actually very difficult to understand when you were successful in running an attack, right? As a human, you start to recognize patterns of, oh, this is weird. This behavior is unexpected. But that is not as binary as software would expect it to be. Meaning that if you are actually running attacks, a lot of it comes down to interpretation and context. This verification step is definitely the hardest part to solve when you're looking at automating attacks throughout using AI. Just going to go quickly through the slides because I do want to go to the demo. Training. We use training data primarily based on bug bounties, bug bounty platforms, and also just books. It's actually funny, we started this company about 4 years ago. The MVP that we built was before ChatGPT was out, but GPT-3 was out there, and we trained GPT-3 on a book, one of my favorite books, which is actually not at all about cybersecurity. It's called PHP 4.0 because it's an old book. It's a book that I learned how to program with when I was very young, but it gives you very rudimentary understanding of how very simple attacks and how to prevent them. PHP 4.0 was around the time when security as a field became more relevant. Obviously, there's many other books now available that basically explain how attack vectors work, and this is something you can literally just put in a rack, give it to an LLM, and it will be able to perform attack based on that. Nowadays, you want to be more targeted, more specific. You need to understand specifically what type of software it's looking at and all that kind of stuff. So you're adding a lot more data into the overall training set. But the very first step was just based on very common knowledge. When I talk about safety, it's actually about validating that when you generate an exploit, you can actually run it safely. This is obviously something that threat actors don't need to do. Because they are not intending to not cause harm. But when we are doing the equivalent from a proactive standpoint, we kind of need to make sure that we're not dropping tables and whatnot. Actually, one of the simpler steps in this whole process, because LLMs are incredibly strong at interpreting code, so you can just give it the exploit that you generated and more or less prompt it, context it, to ask how likely it is to cause harm, and then change it based on that. I can actually give you an example in the demo in a bit. So how would this look like with a very simple SQL injection? You have an agent, goes to a website, finds endpoints that contain data. You start producing exploits for those endpoints, test them, make sure that you can run them safely, and then validate it based on some kind of metric that you set. SQL injections tend to be fairly easy because you can usually slow the system down a little bit, or you can have some other type of error message that gives you an indication that you were successful. This becomes a lot more complicated when you do it at scale. Just to give you a bit of context about Hadrian. Hadrian are now 4 years old. We, like I said, work primarily for larger enterprise. There's include companies in the Netherlands like big banks, but also companies like NBC, Pepsi, McKesson in the US. Those are companies with hundreds of thousands of applications. To be concrete, we run around 25 million attack simulations every day now. That generates about 25 billion in logs. I was invited actually this year to the Zandvoort GP on the cost of Amazon because we've become one of the largest users in the Netherlands on their cloud resources. Because we do host most of it locally here in the cloud. Scale is the real issue when you want to solve this problem, but it also works on the local level. You cannot train a single large language model, at least right now, to solve all your problems. You have to be smart about it. And the setup that we built for that is basically an orchestration layer. And the orchestration layer, you generally use the most recent model because they're strongest. And it's the brain of the operation. It's deciding how to approach a target and how and what to do to automate it. And then you give it tools. That perform a very specific task, right? That task can be find a SQL injection, or it can be run a port scan. It can be take a screenshot. Many different tools. At Hadrian, we have around 250 individual modules that the AI can interact with. The idea is that you train a specific model to be extremely good at one thing. And also it means that one thing, you can guardrail it very strictly around preventing hallucinations and whatnot. If you basically give the scope too broad to any LLM, it becomes very difficult to interpret how real the outcome is. At some point, these models start hallucinating, and you need to prevent, or at least recognize when that happens. So how does it look like with Hadrian? Well, like I said, we have around 250 individual modules. We split them basically into 3 different parts: sense, plan, and attack. So sense is about gathering intelligence, understanding what you're looking at, building the context around an asset, around a company, everything you want to know about it. Plan is understanding then how you can approach that, right? So you understand what type of technologies they're using. Okay, then you also know what type of vulnerabilities they might have historically, and you can start building exploits in the attack phase. It's not just vulnerabilities that it exploits. Misconfigurations, it uses dark web intelligence in their attack phases as well. If one of your credentials or one of your employees has leaked something, we can use that data in an attack scenario as well. And it's also very strong at being very real time. Like I said at the beginning of the presentation, you see that the attack factors and attack scenarios have gone down in time to exploitation quite significantly, and it's usually now within a couple of days that a new zero-day sees exploitation in the wild, and sometimes even a couple hours. I have actually quite a couple examples, but this one I like. It's a cups example from last year, where basically everyone was very hyped about a new, almost critical Linux bug. Turned out it was not too bad, because it had a very strict, narrow set of circumstances that became relevant. But on a Friday around 5 p.m., one of the developers sent a GitHub commit with the patch notes. Somebody was obviously able to reverse engineer that almost immediately, and the public was made aware of this new bug in Linux. It took our system about 2 hours to get that threat intelligence. We buy it externally. LLM then built basically an attack template based on that threat intelligence, merged it with our repositories, and we started scanning our customers for it. And basically the same day, or the same evening, within 3 hours, we had scanned all of our existing customers, and we also had scanned basically all IP4s in Europe, found around 2,500 vulnerable instances. Funnily enough, it was mostly universities and porn that was vulnerable for this. Don't know why. Time for a quick demo. I do want to have some time for questions at the end, so I'm just going to go quickly through it. So what I'm just running here now locally on my laptop is a very small machine, large language model. So it's not like one of the big labs. It's actually a very small one, and that can just run on the laptop. What I started doing is basically asking, hey, I made this website. It's a juice shop environment, very simple, very well-known, vulnerable software. And I just said, hey, can you try and attack it? The first thing it did was just, starting a Chrome instance, saying, hey, I'm just going to run a browser to see how I can approach it. Well, it's a website, so yeah, you should be able to approach it. And then it started analyzing all the responses that it got, saw all the files, started finding also the endpoints, analyzing JavaScript, finding the variables that were being used, input variables in the DOM, everything that allows him to basically understand where a potential endpoint could exist. There are some other side contexts that he discovered, especially around cookie configurations and also some HTTP defense flaws. So just standard misconfigurations that generally would be considered hygiene, but can obviously be changed in an attack. So after this, it basically said, look, I found a couple of fields that I can submit. And in one of the fields when I submit it, it's reflected in the DOM after I send it back. And based on that interpretation, he's like, hey, this is actually quite interesting. Because if it's reflected, it might actually be vulnerable for cross-site scripting. It generates 6 example payloads of how a cross-site scripting could look like, something that then done completely autonomous, and then it started performing the attacks. It's actually going to do a quick safety check as well to see if those cross-site scriptings can be executed safely, but obviously it can because it's a cross-site scripting. It runs the attack and it analyzes the results live now as well, and you see that 4 of those attack vectors were unsuccessful and 2 of them were successful in its execution. And now I could actually just load up the website and show you that these 2 attack vectors can be used against this website. But this is obviously a very simple example, and a standard vulnerability scanner would have been able to find this. Like, let's not make it bigger than it is. The point is that this model was never told to be a vulnerability scanner, right? We actually didn't train it to be a vulnerability scanner. We gave it a very broad range of context in this case. It was actually just a very basic LLM. The power of these tools becomes exponentially more once you are making them very targeted and basically guiding them in this multi-step approach. And we actually have a case study on our website as well, where we were able to identify a Java environment, start finding sensitive file paths, finding exposed heap dumps, exploiting the heap dump to show some credentials to their Google Cloud environment, use those credentials in a Google Cloud environment, and then gaining full access and move laterally within the cloud as well. all done completely autonomous by an LLM agent. So I'm just going to go quickly back to my slides and talk a little bit about how this fits in a general thesis around exposure management that Gartner really loves to sell as well. And we're not a full-fledged exposure management provider because we just do externally facing assets. We just do the external attack surface, so to say. But you see an interesting development in this space in the last, I'd say, 3 years. Where it started out always as a very reactive tool where attack surface management was more or less an Excel spreadsheet that you have of assets that belong to you that are internet facing. It became more and more a proactive way to inform your company, your business, about risks that you might have on the internet facing front. And it became less and less of a hurdle or something that you had to go through as a security analyst. It became a tool that you can use to actually inform and proactively address some of these issues. Reactive, like I said, started with annual testing, some pen testing, etc., manually having an asset inventory. You see that afterwards there were some new tools like RiskIQ, like Expanse that became automating that, at least that inventory, and you started using more periodic pen testing as well. The maturing, you see that there's also quite some work on the actually automating vulnerability scans on a daily basis, something like that. And now you're seeing in the last version, you're seeing the most proactive ways. You fully integrate it with threat intelligence, you fully integrate it with AI, and you basically allow an agent to do the whole SOC workflow that you would otherwise have done manually in an autonomous fashion. So this is also where we fit the bill. We build a platform that is still completely external, and there's a lot of things we don't do, but on this side you can see exactly what we do, right? We're a combination of external attack surface management. We're also one of the highest performers in the Gartner report on external attack surface management. We do a vulnerability scanning, we do that through traditional methodologies, and also through LLM exposure, and we do the active risk validation and all the exploitation chains. And this is actually something that I think is, especially for the type of customers that we work with, larger customers generally, large, I mean at least 1,000 employees usually, complex old infrastructures, partly on-prem, partly on cloud, a lot of SaaS comes into the mix sometimes. You name it. The beauty of using LLMs for this is that it's a super flexible system in terms of what you can look at. So we're also one of the actually only Dutch companies that has been named consistently in the security reports from these analysts like GigaOM, Frost & Sullivan, and Gartner. It's something we're definitely very proud of. And then we have a lot of customers that we are very happy to call our partners. That's it for my presentation. I actually went through it a little bit faster than I had expected. That's what happens when you try to cut it short. Are there any questions from the audience?
Mag ik weer de Nederlandse?
Zeker.
Heel veel klanten waarmee ik in gesprek ben over heden, die geven ook aan van joh, wij zetten het platform in om ook eens te kijken van wat ons merk nou eigenlijk doet daarbuiten. Om nepwebsites tegen te houden en dan eraf te halen. Is dat ook iets waarvan je zegt, nou wij zien het ook heel veel en dat is een hele andere manier waarop mensen onze oplossing gebruiken?
Yeah. So let me quickly rephrase the question. So one of the questions is about brand protection and how we see tools like Hadrian also being actively used for brand protection. And I think it's a really strong tool for that category of problem, right? I think, by the way, generally our strategy is to, as we build our platform and we build new features for our customers, we try to add new categories of problems so that there's also a cost-saving aspect for whoever we work with. Brand protection is one of them that we released last year, and it's actually quite a simple and logical next step. We already had the whole infrastructure to basically find all your internet-facing assets. One of the side catch, so to say, the bijvangst that we get from that is generally infrastructure that looks a lot like you but might not be you. And then on top of that, you do some validation. You do this based on seeing how the color codes correspond, how the logo, some image recognition, that kind of stuff. And you can validate that something is you or not. And brand protection has become a core use case to use this tool as well.
Leuk om te zien hoe dan mensen de oplossing gebruiken naar hun eigen behoeften.
Yeah, no, but like I said, it's really the idea that you, as a platform, you grow and start tackling more and more problems. Right? Dark web intelligence is another one. I was always super frustrated with, in my previous role, when I was buying security tools, that dark web intelligence is such a passive data set. Right? Like, okay, it's interesting to know, but I don't really care anymore about that password that was leaked in 2018. I want to know what's new and how that's relevant. And one of the things that we were able to do is say, well, we get the same data. We actually buy it from a third party. We're not building our own dark web scrapers. We buy the dark web intelligence from a third party, and we use that in attack scenarios. So we now know, okay, we can actually log in through that one password that was leaked 5 years ago, or we can't. And that we can't is just as much a validation step as it isn't, right? Because just knowing that there's something you cannot do means that you save time from whatever analyst is going to have to look at this issue or the CV or whatnot. Any other questions from the audience? Perfect. Then we're going to send you back to lunch early.